Drop your phone face down and the screen survives. Yet 6 months later, hairline scratches you never saw yourself make. Two rival materials explain it: Gorilla Glass and Sapphire, sitting at 7 and 9 on a scratch scale. Here's why you should care. That material choice quietly decides your phone's fate: scratched up in your pocket or shattered on the pavement. And the obvious guess, harder is just better, is wrong. Hardness and toughness are two different properties, and a phone maker has to pick a side. One screen can't win both fights at once. Start with the ruler everyone uses to measure scratching. It's called the Mohs scale and it runs from 1 to 10. Talc, soft enough to crush with a fingernail, sits at 1. Diamond, the hardest thing we know, sits at 10. The rule is simple and brutal. Anything higher on the scale can scratch anything lower, and nothing lower can touch it. A 9 scratches a 7. A 7 can't mark the 9. Now place our players on that ruler. Diamonds at 10. Sapphires at 9. Gorilla Glass lands around 6.5 to 7. So in your entire daily life, only two things, diamond and sapphire, are hard enough to scratch each other. Everything else just slides off. But here's the part that actually matters for your pocket. What scratches a phone in the real world? Not diamonds. Sand. Ordinary sand is mostly quartz, and quartz sits right around 7 on that same scale. Sit with that number. Sand is a 7. Gorilla Glass is a 7. They're tied. When grit from your pocket, your bag, your car cup holder drags across the glass, it's hard enough to bite in and leave a mark. That's your hairline scratch. Now run the same sand across Sapphire, a 9. The quartz is softer than the crystal, so it can't get a grip. It slides off and leaves nothing behind. Same pocket, same grit, completely different outcome, decided by a 2-point gap on a 10-point scale. So Sapphire clearly wins the scratch test. Which raises the obvious question, why isn't every phone screen just made of sapphire? Here's the answer, and it starts inside the glass itself. Gorilla Glass isn't just poured and cooled, it gets a chemical bath that toughens it from within. Picture the glass as a wall of packed marbles, each marble a sodium ion, a tiny electrically charged atom. The glass goes into a hot bath of potassium salt. And potassium ions are bigger marbles. In the heat, the small sodium marbles near the surface swap out, and larger potassium marbles wedge into the same gaps. That's the whole trick, and it has a name: ion exchange. Now think about what you just did. You've crammed bigger marbles into spaces built for smaller ones. The surface layer is jammed, squeezed under constant pressure. Engineers call it compressive stress. And that squeezed skin is the secret. A crack can only spread when something pulls the material apart. But this surface is already being pushed together hard. Before a crack can even start, it has to fight through that whole compressed layer. So when your phone hits the pavement and the glass flexes, the screen bends, absorbs the blow, and springs back, instead of splitting open. That's why Gorilla Glass survives the drop that should have killed it. It's not that the glass is unbreakable. It's that the surface is preloaded to resist cracking. But notice what that squeezed, springy surface is built to do. It's built to bend and survive impact, not to be hard. Which points straight at Sapphire and why it plays the opposite game. So what is Sapphire really? Not glass at all. The sapphire on your watch isn't the blue gemstone. It's clear, and it's a single crystal of aluminum oxide, the same mineral geologists call corundum. And single crystal is the key phrase. Ordinary glass is a jumble, atoms frozen in a messy tangle. Sapphire is the opposite. Every atom locked into one perfect, repeating grid grown slowly from a pool of molten aluminum oxide heated past 2000 degrees Celsius. That rigid, orderly grid is exactly why it's so brutally hard. There are no loose gaps for a scratch to exploit. The whole structure holds together in lockstep. That's how it earns a 9 on the scale, hard enough to shrug off nearly everything a pocket can throw at it. But and here's the trap. The very rigidity that makes it scratch-proof is what makes it fragile. Think back to Gorilla Glass. It survived the drop by flexing, by bending and springing back. Sapphire can't do that. That perfect grid has no give. When it hits the ground, it can't bend to soak up the energy, so the shock has nowhere to go. It builds until the crystal simply gives way and cracks, often straight through. So sapphire is harder than glass, yet more likely to shatter. Harder and more breakable at the same time. That sounds like a contradiction, and it's the single most important idea in this whole video. Which means the real question was never which one is stronger. It's strong against what? Now we can say the trade-off out loud cleanly. Hardness and toughness are not the same property, and they pull against each other. Hardness is resisting scratches. Toughness is resisting shatter. Sapphire's rigid crystal makes it hard, so it wins the scratch test hands down. But that same rigidity makes it brittle, so it loses the drop test. Gorilla Glass makes the opposite bet. It gives up some scratch resistance so it can flex and survive the fall. There's no free lunch. Push one property up, the other comes down. But scratch versus shatter isn't the only thing separating them. Follow the money. Growing a single flawless sapphire crystal means holding aluminum oxide molten above 2000 degrees for days, then slowly pulling one crystal out. That's slow, and it's an enormous amount of energy. Sheets of chemically strengthened glass roll off a line far faster and far cheaper. By rough industry estimates, sapphire can run several times the cost of an equivalent glass panel. Cost isn't the end of it. Sapphire is denser, so a full sapphire face would make your phone noticeably heavier. And it's slightly less clear, so the screen would look a touch dimmer and eat more battery to stay bright. Added up, heavier, dimmer, and multiples more expensive to protect against scratches, while getting worse at surviving the drops people actually have. That's why you don't see all sapphire phones. Instead, sapphire gets reserved for small, high-value protected pieces, watch faces, and the little lens covering your camera. So which failure does a phone maker choose to protect you from? That's the bet the whole design comes down to. So the 7 and 9 from the very start aren't just numbers on a chart, they're the whole story. Sapphire's 9 is why it barely scratches. Pocket grit, sand, keys, all softer than the crystal, so they just slide off. Gorilla Glass's 7 is why the same grit leaves those hairline marks. Sand and glass are tied so the sand can bite. But that lower number is also exactly why the glass survives the fall the sapphire might not. Here's what that actually means for the phone in your hand right now. A mostly glass screen is a deliberate engineering bet. The makers looked at how phones really die, and the answer is drops, not scratches. So they chose the material that survives the fall you're going to have, and accepted the light scratches you'll learn to live with. Scratches are cosmetic. A shattered screen is a dead phone. That's the compromise the whole industry landed on. Strengthened glass for the big screen you drop, and precious little sapphire saved for the small parts you need to stay flawless. The watch face and the camera lens. Different jobs, different material. One phone, both bets, placed exactly where each one pays off. So it comes down to one line. Scratch resistance and shatter resistance pull against each other, and your screen is a deliberate bet on which failure you'd rather live with. Go check what actually covers your phone, the big screen and that little lens. You might be carrying both bets at once.